All right. Normal distribution, we talked about it. I wanted to talk about the fact that when you have a normal distribution, and not everything in life is normally distributed, okay? Not everything in life is normally distributed. Just certain things are. Okay? By observation, later on, we're going to actually test whether or not data is normally distributed. Did you know that popcorn, when you put it in the microwave, did you know that if you were to graph the pops, it would be a normal curve? Like pop, 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 right? Cool. So popcorn is also normally distributed. The frequency of the pops, right, is normally distributed. So that's kind of cool. In nature, right, living creatures, a lot of them follow a normal distribution. A lot of their habits, patterns follow a normal distribution. So that's why that's such a big deal in statistics. Okay? So one more thing. Before you start, before we get going here, this right here, look up here at the screen. That is the width of a bar. The width of the bar is determined by what? The width of the bar. Standard deviation. Unfortunately, my graph right now, I can't move things. But this bar could be opened, right? It could be actually much wider than what we have right here. It has to do with the standard deviation. If the standard deviation is 100, boom, this thing will be much wider. If the standard deviation is 0.5, this bar will be very, very narrow. Okay? So these distances, they should all be the same in terms of, the distance in between should be the same between them at all times, but how wide they are is determined by the standard deviation, okay? As well as where the middle is determined by the mean, the average. The mean determines where the tallest point of my curve is going to be. And it is symmetric. So I usually, when I graph this, I start there and then I move down to either side. Okay? You know your percentages. This is the empirical rule, 68, 95, 99.7. Maybe I want you to add here that plus or minus 3 standard deviations results in us having 99.7% of data points in there. Plus or minus 2 standard deviations results in 95% of our data being in there. What does it mean, plus or minus, Mr. Dirksen? It is from the mean. So if you were to go 2 standard deviations to the left or 2 standard deviations to the right, that's 4 in total, you'd have 95 in there. Plus or minus 1 standard deviation would have 68% of your data in there. Okay? That's something we need to observe before we can say data is normally distributed. Okay? Let's go to page 25. I talked briefly about z-scores. Okay? It tells us how many standard deviations above or below the mean your value is located. A negative z-score means that you're below the mean. A positive z-score means you're above the mean. So if you have a mark of 85% and that 85% is associated with a z-score of 1.8, that means that 85% is 1.8 standard deviations above the mean, above the average. Okay? Next, we talked about the heights of males in Canada. Okay? And we put the mean right down in the middle, and then we added a standard deviation as we went to the right. We subtracted standard deviations as we went to the left. We filled it with percentages. And then we answered a bunch of questions based on that curve. You're with me, right? Very exciting stuff. Okay. All right, let's keep going from there. So we figured out percentage between values. We figured out percentages where we had to like figure out the areas and add them up together. Right? Like over here, we had to figure out what's this, add it up. Okay. Then in E here, let's go over to the to page 26. It said what range of heights would have 99.7% of males, and 99.7 we figured that it's between these two heights. 95 we went to 2 standard deviations to either side. 68 we went to 1 standard deviation to either side. So these are the ranges that we're talking about. And obviously the bigger your range, the more people are going to fall within that, the more data points, right? As you narrow your range, you make it smaller, you can have fewer in there. Next, if Canada has a male population of about 17 million, so if you need to put some commas there, determine the number of males that are shorter than 172 centimeters. Number, not percentages. So start with percentage of males. That's what we're going to start with first. Percentage of males shorter than 172 centimeters. What would that be? We've got to go to our graph. Sorry, I'm going back and forth, but I think it's important right now. So I go to my bell curve. 172 is right there. You want shorter than 172, so everything to the left of it. So we need to add up these two percentages to figure out the percentage of males that are shorter than 172. Okay? So we come over here, and we go 0.15 plus 2.35. That is 2.5% of males. Okay, so that would represent a very small percentage of males. So that would be 1 mark in my books. Number of males. We would simply take this, divide it by 100, okay, and then we multiply it by the number of males in question. Here you have to round. You have to round to a whole number. This happens to give you a nice round number. Okay? This just happens to be a nice round number, but you have to round because now we're talking number of people, right? So that's how many are shorter. What percentage of males have heights with a z-score between -2 and 1? I want to explain this one. Okay? Please draw a little bell curve here. And this is what I do a lot. I go with the middle. This is my mean, right? X bar or mu, whatever you want to, or meow. No, that's not it. Never mind. 3 this way, and I go 3 that way. That's what a bell curve normally has. It has the mean and then 3 to either side. Okay? When it comes to z-scores, mean is represented by 0. Like if you have a z-score of 0, that means that you're exactly where the average is. A z-score of 1, positive is here. A z-score of 2, z-score of 3. Z -1, -2, -3. This is your z, right? what actual heights are associated with, like we want to go with this one here, a z-score of -2 and a z-score of 1 right here. If you go look at our original, what height goes with -2? 172, thank you. And +1? 179.5, thank you. So these are the two heights, right, that go with that z-score. Okay. So let's go here. 172 centimeters. Oh no. This is not what it's asking for. It's asking for percentage. But that's okay still. We want from here to here. We want to know everything that's in this, in between these two z-scores. This is 34, this is 34, and this is 13.5, right? Because this is the middle of the bell curve here. It goes like that, right? So if you want to turn this into bars, it's these three sections you must add up in this case. So it's 13.5 plus 34 plus 34. That is 81.5%. So sometimes it's these scores, sometimes it is the actual height, okay? All right. What is the range of the heights that would have 95% of males comprised in it? We already did this earlier. I'm just going to do this again. 172 to 182 centimeters. And because you're going to look at your notes later on, this is your mean here. So from that tallest point, the curve goes down like that. And so we've got 2 bars this way, 2 bars that way. So here is 172, and here is 182. And we know if you want to go at top of this curve here, we know that if you take 2 to either side, that's 95% of data points. Write this down underneath 95 plus or minus 2 standard deviations. That way you know from the mean we're going to go 2 to the left and 2 to the right. Okay. Next, the mean height for females is 162.5 centimeters with a standard deviation of 3. Sketch both curves on the same plane. How will they differ? Right? Use different colors or patterns to illustrate the differences. Okay, let's do this side by side. Males. What is the average and what is the standard deviation for males again? The average is 177 and the standard deviation 2.5. Okay. Females. We were just told the average is 162.5. Standard deviation is 3 centimeters. Yeah. Let's talk about the mean first. Which one is going to be higher up the x-axis? So let's make our plane here. I'm going to use a ruler for my This is just a sketch, okay? This one is going to be higher up the x-axis, the males, right? So we're going to have males here This is 177. And the females, they're like, so basically for the females, the average is going to be more like here. That's going to be, this is going to be representing the middle of their bell curves. Okay? Which one of these is going to be resulting in a flatter curve? This one or this one? Females is going to be flatter. Okay? Greater standard deviation, therefore flatter. Spread out. So this is what we do, guys. So this one is going to be steeper, right? Let's do this one. Steeper. Just looking at their standard deviations. So you go to the male center, you make that one taller, make a dot right above it. You go to the female one, you make that one shorter, not by much, flatter, not by much, because the standard deviation isn't that different. Okay, like it's not, it's 0.5. So you go to the males and then you go like this. And we're going to go dashed lines, a dashed line with a female bell curve. There you go. That's what you would observe if you graph them on the same axes. Okay, you would observe that. So, and the key here is the middle, right? The average is lower. So along the x-axis, you're going to be lower for the female heights, the average, and therefore males are higher up. And the standard deviation told me, oh, okay, the lower standard deviation goes to the males, which is makes it steeper. Everything's going to be a bit more compressed, okay? And so that's how it goes. So we should probably say here, females and male, okay? If you want a color, you can highlight at least one of them, okay? That way you're like, okay, I know sometimes the pattern isn't as obvious. Okay, so there you go. And maybe I'll say this steeper lower standard deviation. That's why I made that one steeper. So it should be a bit taller than the female one. Okay, calculate the z-score. Calculate the z-score of a male with a height of 181 centimeters. What does this tell us? Calculate the z-score is kind of hint, hint. Use this formula. Z-score is x minus x bar over standard deviation. So basically, 181 is x, right? It's your actual score minus the average is 177, and we divide that by the standard deviation, which is 2.5. If you do this correctly, you could get a negative, but in this case you get a positive. That is positive 1.6. The z-score, you should just look at the z-score, and the positive should tell you that this person is taller than average. How do you know that? Positive means you are to the right of the mean, right? And so that right now, that's all we're going to kind of stick to. This person is taller than average due to a positive Z, okay? Specifically, 1.6 standard deviations above the mean. I will zoom into this because I need you to have that. I need you to have that down. If it had a negative, if your z-score ends up being negative, obviously you're going to be shorter than average. Specifically, right, whatever that number is, that's how many standard deviations below you would be. Okay. Determine the height of a male with a z-score of negative 0.4. That's when you use this formula. You want the actual height, not the z-score. So it's z times standard deviation plus the average. Yeah.
Is the average like the actual thing in the book? Like is this like actually?
If this is true, 177, I'm pretty sure I looked it up.
Yeah.
I have to look it up again to verify. But it could also be that I made it up. And then again, let's talk about this. Every country is going to have a different average, right? So your bell curves would be all over the place. Every country would be like, some would be sliding over to the left, some to the right. Some would be steeper, more consistent. Some standard deviations would be very large. So it would actually be fascinating to go all around the world and see what the bell curve would look like, right? You might not think so, I agree. But z-score is negative, watch this, negative 0.4. Make sure you don't drop the negative, except for if it's attitude, then you can drop it. 2.5 plus 177. You can actually type that all in one shot in your calculator. Negative 0.4 times 2.5 plus 177. That's 176 centimeters. You know why z-scores are actually very helpful? And I'll teach you that later on a bit more. If someone says, hey, dude, I scored 95% on Mr. Dirkson's test. Wow, that's impressive, right? What's your z-score? -2. So you scored below the average. So actually, you didn't do that well compared to the rest of the class. Maybe it was a really easy test, right? Maybe it was really easy, but 95% puts you at -2, like below average. So your average must have been what, like, I don't know, 99%? So z-scores kind of tell us a bit more than just, right, what's on the surface. It tells us where do you compare to the rest, okay? So that's where it's at. All right, I'm going to pause here a bit. I'm going to ask you to practice the concepts that we've been covering. And yes, it will be maybe a little frustrating. That's fine. You have to kind of get down and play in the mud, right? Get dirty. Okay? So because this one is Scratch, I'll help you one more time with the graph. Okay? So that you do the answers, I'll help you with the graph. So this is on 27. The volume of pop cans is normally distributed. So for now, everything is going to be normally distributed for us. Okay? No questions about that. The mean volume of a pop can is 355. the standard deviation is 2.75. Graph a normal distribution curve showing the probabilities for plus or minus 3 standard deviations. Include the z-scores. So I grab my ruler, try to make it look nice, okay? So I will actually use these markings on here, on my ruler. Okay, so I will say this is my mean. So it's 1, 2, 3. Going that way, maybe I'll extend it a little bit. Put an arrowhead there. And go 3 standard deviations to the right. Okay, so you go 3 and 3. Make sure your average is right in the middle. This is your 355. And you've got 3 standard deviations to either side. Call this volume in milliliters. And grab your, I'm going to just say grab your calculators. So many students try to do mental math and then they get it wrong. 355 minus 2.75, that's 352.25 minus 2.75, keep going. That's 349.5 minus 2.75. That's 346.75. Okay? And then you do the same thing to the right, you add. It's 357.75, 360.5, 363.25. I just don't want you to do this blindly, okay? Listen to this part. This is your mean. Bless you. I'm going to label the mean. This is, if you go all the way to the right, it's how many standard deviations to the right? 3, right? Watch this, it's going to blow your mind. You could go 355 plus 3 times 2.75. 3 standard deviations to the right. Hit enter. You should get that 363.25, right? So there's different ways of filling this in, but I like the adding and subtracting as I go. The z-scores, we're going to put them down right here. The z-scores, you put 0 right under 355, 1 goes right under 357, 2, 3, -1, -2, -3. You're not done yet. Okay, make sure you have all those pieces in there. For now, we don't know any better, but I'm telling you already that down the road we're gonna be able to figure out any value in between. Okay, so that's coming your way soon. You go to your mean, just go and make a high mark, right? Follow it as best as you can. Make a dot right there. And then just go out and down. Arrowhead. Do the same thing to the other side. And then slice it up. Slice it up, and we know that this is 34, 13.5, 2.35, and that sliver in there, I should have probably done a better job, but in here it's 0.15. And then fold it over and do the same thing to the other side. 34, 13.5, 2.35, and an arrow 0.15 at the tails. Those are like the tails. Okay. And remember, if you go to the middle and you want to know percentage to the left of it, that's 50%. This is 50%, right? So use symmetry to help you out. You got your graph? Does it look nice? No? Doesn't look nice? It looks nice? Just don't make it look, don't go straight down like that, right? It's not one of those. It's a nice bell curve, okay? So what percentage you have to ask? Does it ask for percentage or does it ask for number of cans? If it's number of cans, it needs to tell you how many were produced. Another word for percentage is probability. Make sure probability. You're not thrown off by that. There's a likelihood or a chance that you land in a certain bracket, right? Okay, if you want if you want to know the percentage or probability that a can will have a volume of at least 360, that means 360.5 ml or more, okay? That's what it's saying. So what would we have to add up? 2.35, right? So anything 360 or more. So you have to add up these two percentages there. I would like you to show me the work just in case you get it wrong. It's 2.5%. That's it. So have fun with it. Use formulas. I will let you work 27. Keep going, 28 to 30, I think. It goes to 30, perhaps. Yes. 30 is a blank page. No, 30 is not a blank page. 30 is still work. So for now, you just work. And I'll come and see if you're actually making progress, right? Page 27 to 30 until we decide to